In this next video, we're going to look at trigonometric functions of angles. So to begin, we're going to recall, given a point P on the unit circle, on the terminal side of an angle T, we find the sixth trigonometric function as defined by the values of x and y. So if you recall from the unit circle, we said that sine of t would be y, cosine of t would be x, tangent of t is y over x, etc. Okay? We are now going to extend this notion to circles of other radii. So maybe we have a circle of radius 10 instead of radius 1. We still want to be able to find the trigonometric functions associated with that. And so what we're going to do is we're going to take a point P of xy on the terminal side of theta, which is a central angle in a circle of radius r, and we're going to define the trigonometric functions as follows. So notice here that each of them are very similar to what we had before. The only difference is r is not necessarily 1 here. R is going to be defined by the square root of x squared plus y squared. So sine of theta is going to be y over r. Cosine of theta is going to be x over r. Tangent of theta is going to be y over x. Cosecant of theta is r over y. Secant of theta is r over x. And cotangent of theta is x over y. And again, remember that x and y cannot be 0 whenever they are in the denominator. So to find correct values for each of the trig functions, you'll need to consider three things. The first is the sign, positive or negative, of the value. Remember that all students take calculus. So remember, all of your trig functions are positive in the first quadrant, sine and its reciprocal are positive in the second quadrant, tangent and its reciprocal are positive in the third quadrant, cosine and its reciprocal are positive in the fourth quadrant. And outside of those, all the other trig values are negative in those respective quadrants. The second thing to remember is the reference angle theta. This is what we're going to use to get the acute angle for our triangles. So remember, there are three instances in particular where we're going to have reference angles. If I'm in quadrant 1, I'm just going to take the angle, with the exception of coterminal angles, and then it's just a matter of putting it back into the first quadrant and the first revolution. But for the other three quadrants, we are always going to measure to the x-axis to get the reference angle. So in the first picture here, if I'm looking at an angle in quadrant 2, then my theta bar, or my reference angle, is the acute angle to the x-axis. So the difference between the pi, or the 180, and my angle. If I'm looking at an angle in quadrant 3, then I'm going to take the angle minus 180 to figure out what the angle value is. And if I'm in the fourth quadrant, then I'm going to look at 2 pi minus my angle, and that's going to give me the reference angle in quadrant 4. The third thing that's going to be needed is my trigonometric identities. So we had a couple of different identities that are useful for solving different trigonometric functions. The first set of properties is that the reciprocal properties. And again, this just gives us our second set of trig functions. So the cosecant, the secant, and the cotangent, but it's also useful for the tangent. So if all you remember are the sine and cosine values, you can still find the tangent and the other three. We also had our Pythagorean identities, the main one being the sine squared theta plus cosine squared theta equals 1. Again, if you know the sines and cosine, you can get the other Pythagorean identities. So dividing out everything by cosine squared, you get tangent squared theta plus 1 equals secant squared theta. Or dividing out my basic Pythagorean identity by sine squared, I get 1 plus cotangent squared theta equals cosecant squared theta. There are other properties that you should remember, things like your even, odd, but in terms of finding trigonometric values, I would say these are the more important ones, your reciprocal and your Pythagorean identities. For later classes, like calculus or calculus 2, for those who need to go on, these are the properties that you are going to have to remember in terms of your basic trig functions. Okay? So given any trig function at a particular angle, to find its value, I just need these three things: the sine, the reference angle, and some of the properties to evaluate it. So let's find the exact value of the following trig functions. So here we're given the sine of 150 degrees. Now again, we're doing similar things to what we did before. The main difference is now we're dealing with degrees, and we may or may not need to convert them. Some of your problems, it's just going to ask you to evaluate it directly. Some, it's going to ask you to evaluate and give both the radian measure as well as the degree measure. Okay, so for example, if I said sine of 150, it would say give this the angle value in radians. So sine of what would equal, and then give the value. In this case, we're just finding the values. So again, for sine of 150, the first two things I want to think about is what is the reference angle and what quadrant is it in. So here, 150 degrees puts us in the second quadrant with a reference angle of 30 degrees. Remember, so the 180 minus the 150 gives us the 30 degrees. And in the second quadrant, our signs are positive. So sine of 150 will be the same as sine of 30 degrees, which will equal 1/2. For cosine of 570 degrees, we're going to start the same way. We're going to figure out which quadrant the angle's in. We'll figure out what the reference angle is and determine the sine. So here, 570 degrees is in the third quadrant. It gives us a reference angle of 30 degrees. So 540 would be 1.5 revolutions, and then putting an additional 30 degrees gets us to 570. In the third quadrant, cosine is going to be negative. So our cosine of 570 degrees will equal the negative of cosine of 30 degrees, which will give us a negative √3/2. And then for tangent of 225 degrees, we're going to do the same thing. So we'll start by figuring out which quadrant the angle is in and what the reference angle is, and determine the sine of the tangent. Tangent of 45 degrees, which is equal to 1. Now when you're writing out your solutions, you don't have to draw the graphs that I've drawn or write out that sine or cosine is positive or negative. You just need to be able to show what the reference angle is. So for example, sine of 150 is equal to sine of 30, which is equal to 1/2. Okay. If you go straight from sine of 150 to 1/2, that is also fine, but you need to make sure that your actual sign, plus or minus, is correct. Okay. The last concept that we're going to talk about in this section is the area of a triangle. And so if you recall from geometry, we said the area of a triangle with the base perpendicular to the height is 1/2 base times height. Okay? So if we have a triangle where we know the base and one of the sides and the angle included between those, then we can draw in our height being perpendicular to our base. Now, knowing only A, B, and theta, you may not necessarily know H right away. They may not give this information to you. But what you should notice is because that's perpendicular, we are looking at a right triangle where theta is the acute angle. So we can actually find an expression for H that is related to the angle. In particular, H is opposite the angle of theta, and since theta is included between A and B, our hypotenuse turns out to be B. So this gives us that the sine of theta is H over B, or H is equal to B sine theta. And so putting this together with our geometric formula, where it's 1/2 the base times the height, our triangle turns into giving us the area as the area equals 1/2 AB sine theta, where theta is the acute angle included between A and B. And so for any acute triangle, or a triangle that has an acute angle, and we're trying to find the area, we can always find it this way.